Close your eyes for a moment. Imagine walking through a forest at night. To you, it may feel quiet, still, and dark, but for the animals around you, this same place is alive with signals you cannot see or hear. A deer might be catching faint scents carried by the wind. An owl may be hearing the tiniest heartbeat under the snow, while fireflies send out coded flashes of light invisible to your eyes. The truth is, we humans live in a thin slice of reality, and beyond our senses there's an endless sea of invisible worlds. Animals, large and small, survive by tuning into these hidden frequencies: electricity, magnetic fields, ultraviolet colors, vibrations in the ground, forces that slip past our awareness but shape every corner of life on Earth. Tonight, let's wander gently into this hidden dimension together and discover how animals use invisible senses to live, hunt, and travel. What you're about to hear may change the way you look at the natural world forever, the secret world of senses beyond human reach. Think of the senses we know: sight, hearing, touch, taste, smell. They are like windows, but they are not the whole house. Most creatures on this planet live inside a much wider structure of perception, a palace filled with windows we humans cannot open. To them, the air and water are crowded with messages, electric ripples, magnetic pulls, faint vibrations, whispers of light outside our vision. They move through this with grace, as if the universe itself is speaking directly into their bodies. What does it feel like to see in ultraviolet, to taste the direction of home in a magnetic field, or to listen to heartbeats without sound? For us, it's hard even to imagine. And yet these abilities are not exotic. They are common. Almost every environment on Earth has species tuned to signals beyond our reach. It makes you wonder, do we live in silence, or are we simply deaf to the greater music of nature? When we stand in a meadow, we might think nothing is happening, but under the soil, ants are reading chemical trails like street signs. Above us, bees are navigating invisible lines in the sunlight. And far out at sea, whales are trading songs that bend around the globe. All these things are happening right now, around us, in dimensions we cannot touch. This hidden sensory world shapes every decision in the lives of animals: where they travel, when they feed, how they avoid danger, how they find love, all depend on abilities we cannot share. That's why nature often seems mysterious to us. We watch a bird fly straight back to a nest across continents and call it instinct. But instinct is often just another word for senses we do not have. And here is where the story opens. If animals are constantly bathed in messages we cannot feel, then perhaps the natural world is not silent at all. Perhaps it is speaking endlessly, and only some have the ears, eyes, or skin to listen. Why animals live inside an invisible web of signals? Life has always been about information. To survive, you must know where food is, where predators are, and where home is waiting. For us, this information comes through what we see and hear. But for most animals, survival depends on reading signals humans cannot detect. Imagine it like being inside a giant web. The threads of this web are invisible forces stretched across earth and water. Animals are connected to it every second. Take a wolf trotting across snow. It can smell prey several kilometers away. The scent is part of that web. A turtle swimming through the Atlantic feels the faint tug of Earth's magnetic field. Another strand of the web. An ant carries a grain of food, guided not by sight, but by chemical lines painted across the ground. All of these are strands too. This web is so complete that animals do not think of it as separate senses. It is their world. Where we might see emptiness, they see rivers of information flowing past. For them, every step, every flutter, every call is tied into this hidden network, as natural as breathing. To us it looks magical, but to them It is ordinary life. You can almost picture the earth itself as a great instrument, playing vibrations, light waves, chemical scents, magnetic pulls. Every animal has its own way of listening, tuned to a certain note. Together they create an orchestra where each creature plays by rules humans can barely perceive. And yet this orchestra is the true background of the living planet. To realize this is to feel both small and connected. We are part of the same system, even if we hear only a faint echo of it. It reminds us that our human world, with its machines and lights, floats inside a larger, older design, a design woven by invisible threads that animals never stop reading. The faint electric whispers hidden in water. Water carries more secrets than land ever could. In rivers, lakes, and oceans, electric whispers run silently through the currents. Many animals have the ability to pick up these tiny fields. It is as if the water itself becomes a radio station, broadcasting faint songs of life. Fish moving their muscles create small electrical signals. Even a heartbeat in the dark can become a beacon if you know how to listen. For most of us, this idea is almost impossible to imagine. We look at water and see only reflections and ripples, but for creatures tuned to electricity, every splash is a glowing map. They swim through an environment where the boundaries of bodies and stones are drawn, not in light, but in energy. To them, it is as clear as day, though no sunlight is needed. Picture the ocean floor, silent and black. A hidden crab shifts under sand. It thinks itself safe. Yet in the darkness, electric whispers leak from its tiny movements. For a shark, these signals shine brighter than any lantern. It moves closer, not by smell, not by sight, but by feeling the electric tremble in the water. The prey has revealed itself without knowing. This sense is not limited to hunting. Some fish use it to navigate murky rivers, building maps of their surroundings through electrical fields. Others send out signals of their own, like private telegraphs, speaking to mates or rivals in pulses of energy. To them, water is not silent. It is filled with conversation, carried on lines of charge we cannot follow. It is humbling to realize how much we miss. While we marvel at the surface of oceans, an entire electric dialogue unfolds below. A dialogue older than humankind, spoken in currents and sparks guiding life in the dark corridors of water, sharks feeling the heartbeats of fish through currents. Among all creatures of the sea, sharks are masters of electricity. They carry special organs, tiny jelly-filled pores called ampullae of Lorenzini, that allow them to sense the faintest electrical signals. Imagine being able to feel the heartbeat of a hidden fish beneath the sand. This is the everyday power of a shark. They are predators not because they are strong, but because they are tuned into a sense beyond sight or sound. Think of a dark night in the ocean. No moonlight penetrates, the water is thick, visibility near zero. Yet a shark glides forward with ease. Somewhere ahead, a fish rests, completely still, not moving a muscle. To human eyes, the prey would be invisible, but its heart continues to beat. Each beat gives off an electric signal, faint, but enough. The shark homes in as if following a lighthouse beam only it can see. This ability makes sharks incredibly efficient hunters. They can detect signals as weak as a billionth of a volt. That is like sensing the electricity of a single battery across 1,000 miles, scaled down into nature's design. It gives them power in conditions where no other sense would work. Darkness, camouflage, silence. None can hide a living heartbeat from a shark. And yet this power is not only about hunting. Sharks also use this sense to navigate the vast oceans, feeling Earth's magnetic field through similar sensitivity. To them, the planet itself provides signposts. They are never lost, even in the middle of endless blue. It is as if they carry a secret map, written not in ink, but in energy. There is a quiet lesson in this. We often think of survival as strength, teeth, and speed, but in truth, the deepest survival often comes from awareness, the ability to sense what others cannot. Sharks remind us that the unseen world is where real power lies. Platypuses swimming with electricity as their compass. Far from the oceans of sharks, in the winding rivers of Australia, swims a creature that looks stitched together from several animals, the platypus. But behind its odd appearance lies one of the most extraordinary sensory gifts in the animal kingdom. Platypuses can detect electric signals too, using sensors built into their duck-like bills. As they swim with eyes closed, ears shut, and nostrils sealed, they hunt purely by feeling electricity in the water. Imagine moving through a muddy river where sight is useless. The platypus dips and dives, sweeping its bill side to side like a metal detector. Tiny signals pulse from worms, shrimp, and insects buried under the riverbed. To us, this would be a blur of nothingness. To the platypus, it is a glowing treasure map. Each spark reveals a clue, and in moments, the animal snaps up its prey with precision. The bill of a platypus is packed with tens of thousands of sensory cells, tuned to both touch and electric signals. It is one of the few mammals on Earth to rely so heavily on this hidden sense. In the stillness of Australian creeks, this adaptation turns darkness and mud into a navigable world of information. And there's something quietly beautiful about this. An animal so odd, once mocked as a hoax when Europeans first saw it, carries one of nature's most refined tools. The platypus does not need sharp eyes or loud calls. It carries a different wisdom, the ability to trust what cannot be seen, to swim by faith in hidden signals. This sense is not just a curiosity. It is survival. How rays glide by, mapping the unseen world around them. Picture a stingray moving like a shadow across the ocean floor. To our eyes, it seems to drift lazily, as if carried only by currents, but inside that flat body lies a system of electric sensors, cousins to those of sharks, that allow rays to read the world in ways we cannot. Their wide, wing-like bodies become receivers, tuned to invisible whispers flowing through water. Every flick of a fin sweeps their sensors across sand and stone, painting a map of hidden life. Buried shellfish, half-hidden crabs, even the pulse of a fish under silt, all appear to the ray not in sight, but in patterns of energy. Imagine walking blindfolded through a crowded room, yet still knowing where each person is because their heartbeat glows in your mind. That is how rays move, as if the dark itself is transparent to them. This sense does more than reveal prey. It gives rays a calm confidence as they glide. The ocean for them is not guesswork or danger, but a charted field of signals. Each motion feels purposeful, each turn exact. There is no hurry, no panic, only trust in the hidden currents that guide them, unseen by us. It is easy to forget when we see them lying flat in aquariums that these creatures live in a world thick with invisible geometry. They are architects of the unseen, sketching space with every motion of their wings. To watch them is to see grace, but to feel as they feel would be to live in a reality layered with constant information. The stingray's glide reminds us that even in silence, even in stillness, there are rivers of messages flowing. We may not hear them, but to rays, they are as solid as stone. And in that they reveal a truth. The world is never empty, only full in ways beyond our senses. Birds soaring with the pull of Earth's magnetic lines. Look up at the sky and imagine flying with no map, no compass, no GPS. Yet birds have been doing this for millions of years, crossing oceans and continents with astonishing precision. Their secret lies in a sense humans barely know exists. Magnetoreception. Birds can feel Earth's magnetic field as if it were a silent, invisible thread guiding them through the air. Science still debates how this sense works. Some say it is crystals of magnetite inside their bodies, tiny compasses embedded in cells. Others believe it's in their eyes, where light and magnetism combine to create a hidden visual map. Whatever the mechanism, the result is the same. Birds glide across vast distances, always knowing which way is north, south, east, or west. Think of a robin in spring lifting off from Europe and heading for its nesting grounds thousands of kilometers away. To us, the journey looks impossible without tools, but to the robin, the magnetic field feels like a road beneath its wings. It doesn't need to think. The path is simply there, etched into the sky by forces we cannot see. The pull of magnetism gives birds freedom we can only envy. Where we depend on charts and machines, they carry the map inside themselves. Each turn, each drift of wind is checked against the steady hum of Earth's magnetic lines. To them, the planet itself is alive, always whispering directions, always pointing the way home. And perhaps there is a wonder here for us too. If the Earth is a compass for birds, then the world is more than stone and air. It is a living guide shaping journeys silently. Watching birds in flight, we are not just seeing wings, we are seeing creatures in constant conversation with the planet itself. Migrating geese tracing highways in the sky without maps. When flocks of geese rise in autumn skies, forming perfect V-shapes across fading sunsets, it feels like poetry written in motion. Yet behind this spectacle lies a deep and invisible sense of navigation. These birds follow highways that exist not on land but in the sky itself, traced by magnetic lines, the angle of the sun, and signals only they can feel. Their migrations span thousands of kilometers, from frozen lakes in the north to warmer wetlands far below. What makes it remarkable is that they return to the same places year after year, almost to the exact field or pond. For them, the sky is not blank. It is threaded with signposts we cannot read. Each wing beat moves them along a path older than civilization. The V formation itself is more than beauty. Each bird feels the slipstream of the one ahead, saving energy in a pattern passed through generations. And yet, even in changing weather, they never seem lost. The invisible highways they trace are as real to them as roads are to us. They follow a map, written not in paper but in Earth's own fields and cycles. To stand below such a migration is to feel small, almost humbled. These creatures live in two worlds at once, ours of land and sight, and theirs of unseen guidance and endless sky. Their faith in the path, their trust in forces invisible, carries them further than any human traveler without machines. Perhaps this is why migrations move us so deeply. They remind us that the world has secret order, written in forces that whisper quietly but persist across centuries. Geese do not wonder if the way is there, they simply fly, and the earth itself carries them forward. Sea turtles, finding the exact beach of their birth. Few mysteries of animal life are as moving as the journey of sea turtles. Born on sandy beaches, tiny hatchlings race toward the sea. Guided by moonlight and waves, they vanish into the ocean for decades, roaming thousands of kilometers, and yet when their time comes to lay eggs, they return to the very beach where they themselves began. How do they find it? The answer lies in invisible senses we are only beginning to grasp. Turtles are thought to imprint on the magnetic signature of their birthplace. Every stretch of coast carries a unique magnetic fingerprint, a pattern in Earth's field that turtles remember for life. Decades later, they detect that same fingerprint in the water, guiding them back across oceans with uncanny precision. It is as if their home beach never stops calling them, whispering through magnetism across time. Picture a turtle swimming through endless blue, no landmarks, no smell, no sight of land for thousands of kilometers. To us, the journey seems hopeless, yet to the turtle, the magnetic signals form a map under the waves. Slowly, patiently, it angles its way home, guided not by sight, but by the invisible lines of Earth itself. This journey is not just survival, it is ritual. Generation after generation, turtles return to the same beaches, keeping ancient cycles alive. The invisible sense they carry becomes a bridge between past and present, linking each turtle's life to the land of its ancestors. It is memory carved not into the brain, but into the very body of the earth. When a turtle emerges on sand after decades away, digging a nest where it once hatched, we glimpse the power of senses far beyond our own. What seems miraculous is, for them, simply the way the world has always spoken. Salmon climbing rivers, guided by a magnetic memory. If sea turtles remind us of return across oceans, salmon tell the same story along rivers. Born in freshwater streams, they journey to the open sea, living years in distant waters. Then, as if pulled by fate, they fight their way back upstream, leaping rapids and waterfalls until they reach the very stream where their lives began. This is not luck. It is guided by invisible senses that tie them to home. Like turtles, salmon seem to memorize the magnetic address of their birthplace. As they grow in rivers, their bodies tune into the local magnetic field. Years later, when it is time to spawn, they follow this signature back, swimming against currents with relentless determination. The ocean, vast and confusing to us, holds pathways that salmon feel as clearly as we feel roads underfoot. Their journey is brutal, yet precise. They climb rivers, smelling familiar waters, but always guided by the deep compass within. Every twist of current, every turn of stone is checked against the pull of Earth's field. It is not thought, not decision. It is sensing, remembering, and obeying signals we cannot perceive. The sight of a salmon leaping upstream feels like defiance of gravity itself. But it is not stubbornness. It is trust. Trust in the invisible map that never fails, trust in the path carried in Earth's own fabric. And in their final act, they give life back to the streams where they began, completing a circle as old as mountains. Watching salmon return home tells us something profound. The world is not random for these creatures. It is ordered, patterned, filled with invisible guideposts. To them, destiny is not written in stars. It is written in the quiet lines of magnetism under their skin. The subtle dance of light humans cannot see. Light feels simple to us. We see colors, we see shapes, and we think we've captured it all. But the truth is, the human eye catches only a sliver of the spectrum, a thin window between red and violet. Beyond it stretches an ocean of light we cannot see. For many animals, this hidden light is not extra. It is essential. They live in a world painted with colors invisible to us, a silent dance happening right before our eyes. Imagine a meadow of flowers. To us, the blossoms glow with familiar shades, yellow, blue, pink. But to a bee or a butterfly, the same field is ablaze with ultraviolet patterns. Petals carry landing strips, arrows of light pointing toward nectar. These signs are invisible to humans, yet to insects they are flashing billboards clear as day. Suddenly the flower is not just beautiful, it is a map. This hidden light changes everything. Birds use ultraviolet to recognize mates, distinguishing feathers that to us look identical. Reindeer in the Arctic use it to spot food against the snow, where lichen glows faintly in UV contrast. Insects avoid predators or track mates through signals that play in this secret theatre of color. For them, ultraviolet is as ordinary as daylight. And here is the strange part. All of this is happening right now, around us, as we speak. Our eyes simply filter it away. To us, the world looks quieter, simpler, smaller. But animals live in a painting with extra layers, richer and sharper, each pattern designed by millions of years of survival. What we miss is not absent. It is just hidden, waiting beyond our sight. Perhaps this is why the idea of invisible senses humbles us. It shows us how little of reality we actually perceive. We think we see the whole stage, but we are really watching through a narrow slit. The rest of the play goes on regardless, full of color and detail, shining brightly for those tuned to it. Bees reading flowers through ultraviolet patterns. Take a bee drifting across a summer garden. It hovers near blossoms, wings humming in the heat. To us, it looks like random searching, but in truth, bees are reading messages written in light we cannot see. Each flower carries ultraviolet marks, rings, stripes, and arrows that act as neon signs, pointing the bee toward nectar. It is a secret language between plant and pollinator, invisible to humans but crystal clear to bees. Picture a sunflower. To our eyes, it is a broad disk of golden petals, but to a bee, ultraviolet shading darkens the center, creating a bold target that says, "Come here." Orchids may carry streaks glowing like runways, guiding insects like pilots landing on a strip of light. These patterns are not decorations, they are instructions, evolved over millions of years of partnership. The bee, in turn, carries its own sense of navigation. Once it finds nectar, it remembers the pattern, linking it with the flower's location. When it returns to the hive, it performs the famous waggle dance, a code that tells other bees where to fly. And so, ultraviolet signals on petals ripple outward, feeding entire colonies through this hidden communication chain. It's remarkable to realize how much of the beauty of flowers is actually invisible to us. We praise blossoms for their colors, but we see only half their story. Bees are the true audience. Their ultraviolet vision is why flowers bloom in such diverse designs, evolving patterns for pollinators, not for human eyes. The colors we love may just be side effects of this deeper dialogue. Watching bees at work is like glimpsing two layers of the world overlapping, the human one of bright colors and the insect one of hidden light. It makes you wonder how much of the world we admire is only a shadow of what's really there, glowing in signals we can never see. Butterflies catching glimmers invisible to human eyes. Butterflies have always been symbols of beauty, with wings painted in dazzling colors. But what we see is only part of their display. Many species reflect and perceive ultraviolet light, covering their wings with patterns invisible to us. To humans, a butterfly may look simply blue or orange. To another butterfly, those same wings may blaze with hidden glimmers, secret signs meant for communication, courtship, or warning. Take the common blue butterfly. To our eyes, its wings shimmer in pale hues. But in ultraviolet, males and females look strikingly different. This hidden contrast helps them find each other in meadows, ensuring that no time is wasted in guessing. Some butterflies even signal dominance through ultraviolet flashes, using invisible colors as badges of strength. The story deepens when predators enter the picture. Birds that can see ultraviolet pick up warning signals from butterflies advertising they are poisonous. A predator learns quickly that certain patterns mean danger. Thus, ultraviolet vision shapes not only romance but survival, weaving into the very fabric of who lives and who does not in the natural world. And it isn't just defense or attraction. Some butterflies use ultraviolet as camouflage, blending into flowers that reflect the same hidden light. To us, they are colorful dots against petals, but in their true spectrum they disappear into the landscape, vanishing before the eyes of those who matter most. It is humbling to realize that what we call beauty may be just the faint surface of something deeper. Butterflies remind us that life communicates on channels we cannot see, that wings are not just decoration, but living billboards of light, playing messages across a spectrum hidden from us. Reindeer, tracking the shimmer of Arctic lichen in UV. Far away in the frozen north, herds of reindeer move across snowfields in search of food. To us, snow is blindingly white and lichen barely visible against the ice. But reindeer see in ultraviolet, and this gift changes everything. Against the bright snow, lichen absorbs UV light and appears dark, like a shadow on the ground. For a hungry reindeer, this contrast turns invisible meals into beacons. Think about the challenge. In Arctic winters, days are dim, and snow covers nearly everything. Traditional sight would make foraging nearly impossible. Yet with ultraviolet vision, reindeer can spot food quickly, ensuring survival in one of Earth's harshest landscapes. What to us looks like endless emptiness becomes a dotted map of nourishment to them. This adaptation does more than find food. It also helps reindeer spot predators whose fur reflects UV differently than snow. Wolves, otherwise camouflaged, stand out as dark shapes against the landscape. So, in a sense, ultraviolet sight is both dinner bell and alarm system, guiding reindeer towards safety and sustenance at once. It's extraordinary how a single sensory adaptation can transform an entire environment. The Arctic, which to humans feels like a white desert, to reindeer is a textured canvas full of signals. They are not lost, not starving, but tuned into a secret contrast that reshapes survival. And perhaps the most remarkable thing is this. Humans once thought of reindeer as ordinary grazers, yet within them lies one of the most profound examples of how nature bends senses to the world. To live in snow, they learn to see what we cannot. And that gift has carried them across frozen ages. Mantis shrimp living inside a rainbow of hidden colors. If there is one creature that truly makes us question our own senses, it is the mantis shrimp. This small marine predator carries eyes so advanced that scientists call them the most complex in the animal kingdom. While humans see 3 types of color receptors: red, green, and blue. Mantis shrimp see up to 16. They can detect ultraviolet, polarized light, and perhaps colors we do not even have names for. Imagine living inside a world where every reflection, every ripple, every glint of a shell splits into layers of meaning. To a mantis shrimp, a coral reef is not just bright. It is overwhelming, alive with hidden colors, shifting signals, and coded warnings. They read the world like a book bursting with extra pages, while we see only the cover. These eyes are not just for beauty. Mantis shrimp are fierce hunters, striking with claws that move faster than a bullet. Their complex vision allows them to track prey with precision, seeing the faintest shift in light or camouflage. They can even communicate with each other using polarized reflections on their shells, a private code invisible to most other creatures. It challenges us to imagine what we are missing. If mantis shrimp live in a rainbow far richer than ours, then what is real color? Are we trapped in a duller version of reality, one stripped down for survival? To them, life is brighter, sharper, more alive, a constant spectacle of hues and signals layered beyond imagination. The mantis shrimp is proof that the world is larger than our senses allow. While we marvel at sunsets and think we know beauty, there exists a creature who might look at the same sky and see a dozen more colors hidden within. And that thought alone reshapes how we think about reality itself. Owls listening to silence and hearing heartbeats in snow. In the stillness of winter nights, owls reign as hunters. Their wide eyes may look fierce, but their greatest gift is hidden in their ears. An owl can hear a mouse beneath inches of snow, not by movement, but by faint sounds no human could ever detect. Imagine hearing the soft scrape of a claw under a blanket of frost, or even the rhythm of a tiny heart beating in the dark. Their faces are shaped like satellite dishes, funneling sound into asymmetrical ears, at one slightly higher than the other. This design allows them to detect not only how loud a sound is, but where it comes from in three-dimensional space. In perfect silence, they can build a mental map of life moving below them. It is as if they carry radar in their heads, tuned not to echoes, but to whispers. Owls rely so heavily on hearing that they often hunt in total darkness, gliding silently until the exact moment they strike. The prey never sees them coming. Their wings are shaped with serrated edges to muffle sound, so that not even the wind reveals them. The owl becomes not just a listener, but a ghost in the night sky. There's a strange poetry in this ability. For us, silence is empty, almost oppressive. For owls, silence is the canvas on which sound paints its faintest stroke. What we call stillness is, to them, alive with hidden signals. Breathing, rustling, pulsing. The winter forest is not quiet. It is a library of sounds too small for our ears. Watching an owl is like watching patience turned into power. It doesn't rush. It listens. And in that patience it finds what we cannot. Proof that silence is never truly silent. It always carries the faint heartbeat of life waiting to be found. Cats turning whiskers into radar for the night. In our homes, cats may look like playful companions, but their senses remain sharp instruments of survival. Their whiskers, delicate as strands of silk, are far more than decoration. Each whisker is rooted deep in nerves, able to detect the tiniest changes in air currents. To a cat, whiskers are radar, silent guides in darkness, painting invisible maps of space. Picture a cat slipping through a dark room. Without light, it knows exactly where furniture stands, how wide an opening is, whether it can fit through a narrow gap. Air currents bend as it moves, brushing past obstacles. The whiskers catch these ripples and send information straight to the brain. In this way, the cat never stumbles. It moves like liquid shadow, confident where we would grope blindly. Whiskers also reveal emotion. They flare forward in excitement or twitch backward in caution, as if broadcasting a hidden dialogue between the cat and its world. Each movement is a small adjustment to the unseen signals flowing around it. This makes cats sensitive, not just hunters, but interpreters of spaces invisible to us. Even their playful pounces on toys are guided by this sense. A whisker quiver tells them the exact distance of the leap, the softness of a landing, the size of the prey. It is precision without thought, a constant flow of data drawn from the silent air. Cats live inside a field of awareness that extends beyond their bodies. The next time you see a cat pause and twitch its whiskers, know this: it may be reading the invisible structure of a room, sensing shapes you cannot. What looks like stillness is, for the cat, the world whispering in quiet streams of touch and air. Bats sculpting landscapes out of sound. Few creatures demonstrate the power of invisible senses more dramatically than bats. Blind in darkness, they fill the night with pulses of sound, high-frequency cries far above our hearing. These cries bounce off walls, trees, and insects, returning as echoes. With each echo, bats sculpt the shape of their world, building a living map in sound. This is echolocation, the art of seeing with hearing. Imagine sending out a call, then instantly knowing where every branch, every moth, every wall lies around you. That is what bats do in milliseconds. Each returning echo paints a detail, distance, size, even texture. Together, thousands of echoes create a complete three-dimensional model. To a bat, the night is not dark. It is crowded with vivid shapes, constantly shifting as echoes arrive and fade. This sense is so refined that bats can detect something as small as a mosquito and adjust their flight mid-air to catch it. They can even distinguish between different kinds of surfaces, telling whether a leaf is rough or smooth, or whether water ripples softly below. To them, every sound is a thread weaving the tapestry of the night. What makes this even more remarkable is the speed. Bats live in a world where fractions of a second matter. They chirp, receive echoes, and adjust flight paths almost instantly, weaving through forests at speeds that would leave us helpless. To them, time itself seems stretched, with every echo giving them more awareness than human senses ever could. If you listen carefully on summer nights, you may hear faint clicks at the edge of perception. Those clicks are the outlines of a hidden world, one that bats live in fully. For them, sound is not something to hear. It is something to see. Dolphins drawing pictures with echoes underwater. In the sea, sound carries farther and faster than in air. Dolphins, playful and intelligent, use this to create an extraordinary form of perception. Like bats, they produce clicks and whistles that bounce off objects around them. But their echolocation is so refined that scientists believe dolphins can see detailed pictures of the world through sound alone, perhaps even images of the inside of objects. Imagine a dolphin approaching a fish in murky water. Sight is useless, but a few clicks reveal everything. The echoes return, carrying the outline of the fish, its size, even whether it is hiding behind seaweed. Some studies suggest dolphins may detect air-filled spaces inside bodies, almost like scanning with sonar. For them, sound draws not just surfaces, but depths. This ability makes dolphins master navigators of cloudy seas. They play by bouncing sound off objects, exploring the shapes and hollows of reefs. They communicate too, mixing clicks and whistles into a complex language that may carry more meaning than we yet understand. Each sound is not just heard, it is felt, visualized, transformed into a picture in the mind. Dolphins also seem to use echolocation socially. Mothers click toward calves, guiding them like a beam. Pods coordinate hunts by sensing each other's sound pictures, almost as if sharing maps in real time. It is not just perception, but community, built on the invisible art of echoes. To imagine this is to realize how shallow our senses are in comparison. Where we rely on light, dolphins weave sound into vision, turning the ocean into a constant gallery of moving, echo-born images. What seems like play is, at its heart, mastery of an invisible dimension. Whales singing songs that map entire oceans. If dolphins use echoes to paint small pictures, whales stretch sound across the globe. Their songs, low and powerful, can travel for hundreds of kilometers through deep water. To whales, the ocean is not silent. It is filled with messages, rhythms, and maps carried by sound waves too deep for us to hear. Entire oceans become connected by their voices. A whale's song is not random. Each pattern of notes may serve as a call to mates, a marker of territory, or even a kind of acoustic map. The way sound bends and travels through water can reveal the shape of sea floors, the distance of currents, even the presence of other pods far away. In a sense, whales are cartographers of sound, sketching the world through their music. Imagine being able to shout into the sea and hear the geography answer back. That is what whales may experience. Their calls return altered by cliffs, ridges, and depths. From these changes, they can read the landscape, even without ever seeing it. It is navigation through music, a constant dialogue with the ocean's body. The emotional power of whale songs has touched humans too. Recordings reveal haunting, almost mournful melodies that seem to carry meaning. To us, they are beautiful mysteries. To whales, they are practical lifelines, tools of survival and community. They connect family members across miles of water, knitting lives together in a choir older than our species. Listening to whales reminds us that sound itself can be a world. What we call noise is, for them, the fabric of existence. In their songs lies proof that the ocean is never empty. It is always alive, always singing back to those who can hear. Elephants sensing distant thunder through their feet. Elephants are giants, but their power lies not only in size, it lies in sensitivity. These massive beings can detect vibrations traveling through the ground, sometimes from storms or herds miles away. Imagine feeling a distant thunder rumble not through your ears but through the soles of your feet. For elephants, the earth itself is a messenger carrying signals silently across savannas. Their feet are padded with soft tissue that hides a network of sensory cells. When sound waves hit the ground, from another elephant's call, from a roaring lion, even from far-off rain, the vibrations travel upward, reaching their bones and nerves. The elephant listens through the earth. It interprets low-frequency rumbles that humans cannot hear, turning them into direction and meaning. This ability ties elephants together as families. A matriarch may sense the distant call of another herd, guiding her group toward water or away from danger. Calves follow confidently, never knowing they are walking paths drawn by signals too deep for our ears. The herd moves not in confusion but in harmony, guided by messages flowing invisibly underfoot. It's a reminder of how awareness can be hidden in unexpected places. To us, the ground is solid, mute, unchanging, but to elephants, it is alive, carrying news, warnings, and invitations across distances too vast for sight. The earth is not silent, it is always speaking, and elephants never stop listening. There is something humbling about this vision. A creature so large, yet so attuned, finding wisdom not in noise but in vibrations too subtle for us. Perhaps that is why elephants feel ancient, like guardians of a knowledge rooted not in the sky, but in the trembling soil beneath us. Giraffes, feeling vibrations along the ground. High above the savanna, giraffes tower, their long necks reaching into treetops. We often think of them as creatures of height, but few realize that giraffes, too, are sensitive to the world beneath their feet. Though quieter in nature than elephants, they can detect faint vibrations traveling across the earth, adding another dimension to their watchful lives. When danger stirs, the silent stalk of lions or the sudden stampede of antelope, vibrations ripple through the ground. Giraffes feel these tremors, sometimes before their eyes or ears would notice. It gives them a head start, a silent warning to lift their heads higher, scanning the horizon for shapes of threat. Their towering height becomes doubly effective when paired with awareness rooted in the soil. This duality, of being both sky watchers and earth listeners, makes giraffes unique. They do not live only in one layer of the world. They span from treetop to underground, tuned to both distant signals in the air and hidden tremors in the land. Their stillness when they freeze is not hesitation, it is calculation waiting to confirm what the vibrations tell them. It's easy to see giraffes as gentle giants, aloof and calm, but hidden within their elegance is a network of senses more intricate than we imagine. They are participants in the constant conversation of the savanna, where every step, every roar, every crack of thunder sends messages through the ground. Their gift is subtle, but it carries a lesson. Awareness does not always mean reaching farther outward. Sometimes it means listening downward, letting the earth itself whisper truths we might overlook in our rush to keep our eyes only on the sky. Moles tunneling through touch and earth tremors. Beneath our feet lives a hidden world, dug by tiny creatures who move in complete darkness. Moles, with their velvety fur and spade-like paws, navigate underground not with sight, but with touch and vibration. Their tunnels may look chaotic to us, but to them the earth is alive with signals, the shifting of soil, the flutter of an insect, the pulse of footsteps above. Their whiskers and snouts are lined with sensitive cells, capable of feeling minute tremors in the ground. A worm wriggling nearby becomes a vibration, carried through soil like a ripple through water. To a mole, this ripple is clear direction. It digs not randomly, but precisely, cutting through earth to reach its hidden prey. The darkness is no obstacle. It is simply another canvas for touch. Moles also sense the vibrations caused by predators walking above. Even in total blindness, they know when danger is near, retreating deeper into safety. Their world is not defined by sight, but by pressure, tremor, and movement. It is a constant dialogue between body and soil, where every grain carries meaning. This way of life feels alien to us. We live above the ground, relying on open horizons and vision, yet below a creature thrives by surrendering to the unseen. Moles remind us that survival is not always about seeing farther, but about feeling more deeply what is right around you. When we think of tunnels and burrows, we often imagine confinement. But for a mole, these passageways are highways of information, vibrating with signals of life. The soil, far from dead, becomes alive, a language of tremors that only they can understand. Snakes, tasting the air with forked tongues. Snakes carry one of the most iconic, invisible senses. When they flick their forked tongues, they are not smelling in the way humans do. They are collecting particles from the air, splitting them across two channels, and bringing them to a specialized organ, the Jacobson's organ in the roof of the mouth. And this gives snakes the ability to taste the direction of scents, almost like reading invisible trails painted in the air. Imagine standing in a dark field with no vision. A snake doesn't panic. It simply flicks its tongue, and the air tells it everything, which way prey has passed, whether danger lies left or right, even how far the trail may stretch. Each fork of the tongue is like a sensor pointing in a different direction, comparing signals, giving the snake a three-dimensional picture of scent. This makes them astonishing hunters. A mouse might scurry away unseen, but the chemical trail it leaves in the air and on the ground is unmistakable. To the snake, it glows like a bright arrow. It follows patiently, weaving left and right, adjusting with each flick of its tongue until it closes the gap with silent precision. The forked tongue is also key for navigation and territory. Snakes use it to read pheromones of mates, to track rivals, and to weave silently through their world, guided by signals others cannot sense. For them, the air is not empty. It is a river of taste and smell combined, flowing with messages every second. To humans, this might feel eerie, almost supernatural. But in truth, it is just another reminder that life has many ways to know the world. Snakes prove that even air, so invisible, so overlooked, can be a book if you have the right tongue to read it. Dogs decoding invisible storms of scent. Of all the animals we live with, dogs show us most clearly the power of invisible senses. Their sense of smell is thousands of times stronger than ours. While we see the world in color, dogs see it in scent. Each street, each path, each person leaves trails and layers of odors that to us are silent, but to them are bursting with detail. They walk through storms of smell that shape every step they take. A dog can track a human days after they've passed, following the faint chemical particles left behind in footprints and skin. It can detect sickness, fear, even subtle changes in mood, all by scent. For them, each person carries a signature as distinct as a fingerprint, floating invisibly in the air. To us, two strangers may smell the same. To a dog, their histories are written on the breeze. This gift explains why dogs can detect explosives, drugs, or illnesses like cancer. What machines struggle to find, a nose tuned to invisible molecules identifies instantly. Their awareness is not magic. It is biology sculpted for survival, turned into companionship and service alongside humans. And yet it's not only about tasks. Dogs read the world emotionally through smell. They know when their humans are stressed, when another dog is nearby, when a storm is coming. Their invisible sense ties them constantly to the present moment, weaving them into the living fabric of air around them. Where we drift in thought, they are anchored in sensation. Watching a dog sniff with purpose reminds us of our own blindness. We may believe the world is simple, but to them it is layered, rich, and full of signals we miss. And in their quiet way, they invite us to trust that there is always more around us than we can see. Wolves following an odor trail across frozen miles. Picture a pack of wolves moving silently across snow. Their noses lead them more than their eyes. For wolves, scent is a thread woven through air and ground, one they can follow across frozen miles. A faint odor carried by wind becomes a story, the direction of prey, its health, its fear, its distance. Where we see only emptiness, wolves smell entire histories drifting through the cold. When a deer passes through a forest, it leaves behind invisible clouds, from breath, from fur, from skin. Hours later, wolves arrive, and the trail is still fresh to them. Each wolf lowers its head, inhaling the scent, weaving together clues. It is not guesswork. The odor grows stronger or weaker, sharper or fainter, and the wolves adjust course as one. Their unity is not only social, it is sensory, a collective trust in signals too faint for us. This power allows wolves to track prey across astonishing distances. A scent may fade for humans after minutes, but wolves can follow it for days, even through rain or snow. Their noses hold hundreds of millions of receptors, tuned not just to what, but to where. It's a navigation system written in molecules, more precise than any compass. But scent is not only for hunting. Wolves mark territories with odor, leaving invisible boundaries drawn across vast landscapes. Other packs respect these chemical lines, reading them like signs. A single patch of snow can tell a wolf who passed by how strong they were, whether they carried young. It's a constant exchange of information without a word spoken. To watch wolves travel is to watch confidence born from unseen maps. They do not question where the path lies. They smell it. For them, the frozen wilderness is not empty but alive with invisible trails, guiding them to food, family, and safety. Ants weaving cities guided only by pheromone maps. Bend down and watch ants moving along a line. They march with purpose, never lost, always aligned. But what seems like simple instinct is actually an invisible system of communication. Ants lay down pheromone trails, chemical signals that act as maps. Each ant carries the power to write and read these maps, turning chaos into astonishing order. When one ant finds food, it returns to the colony, leaving a trail of pheromones behind. Others detect the scent, follow it, and reinforce it with more pheromones. Soon, a faint line becomes a highway, directing thousands of ants to the same source. It's a living road, built not from stone but from chemicals evaporating on the ground. These maps are flexible. If a path is blocked, ants search for new routes, marking detours with fresh pheromones. Gradually, stronger trails replace weaker ones until the colony collectively finds the most efficient path. What looks like intelligence is actually chemistry at work. invisible lines directing the flow of a city. This system also organizes building, defense, and even waste disposal. Entire colonies function without spoken word, without sight of the whole plan. Each ant reads local signals, yet together they create sprawling societies that rival human cities in complexity. It's the hidden language of pheromones that makes this possible. To realize this is to understand that intelligence does not always mean brains. Sometimes it means networks, shared signals, cooperation, born from invisible threads. Ants prove that a society can be built not from sight or sound, but from whispers carried in the air itself. Termites building air-cooled towers with chemical whispers. Deep in tropical landscapes, towering mounds rise from the ground, homes of termites. These structures can reach the height of a man with chambers, vents, and tunnels that regulate temperature perfectly. How do blind, tiny insects achieve such engineering? The secret lies in chemical communication. Termites coordinate their construction through pheromone signals, turning invisible whispers into architectural marvels. Each termite carries no blueprint. It knows only how to respond to certain chemical cues. One lays down a droplet of pheromone, and another feels compelled to place soil there. Slowly, brick by brick, the mound grows. Openings are left where scents signal airflow, while chambers form where different pheromones linger. The entire design emerges from the chemical conversation of thousands of workers. Inside, the mounds stay cool, even in scorching heat. Air circulates through vents precisely angled to balance temperature and humidity. To us, it looks like genius. To termites, it is simply obedience to invisible instructions written in chemicals that evaporate and spread. This system ensures survival not only for termites, but for their fungal crops which they carefully farm inside the mounds. Every chamber, every passage, every vent is tuned to this partnership. The chemical signals that build the mound also protect the delicate ecosystem within. We might think of termites as pests, but their homes reveal a different truth. They are master builders, guided not by plans, but by invisible voices in the air. What they create stands for decades, sometimes centuries, monuments raised by the power of scent. Moths flying straight into invisible perfume trails. On warm nights, moths flutter through the air, often drawn to lights that confuse them, but their true guide is not lamps. It is scent. Male moths can detect a single molecule of a female's pheromone across kilometers. To them, the air is alive with invisible perfume trails leading them directly to mates. It is one of the most sensitive chemical senses known in nature. Imagine a moth gliding in darkness. A faint whiff drifts by, so small that humans could never register it. Yet the moth locks on, adjusting its wings to follow the scent. Each wing beat carries it closer, zigzagging along the invisible plume until, after long pursuit, it arrives at the source. To us it seems miraculous. To the moth it is simply the rhythm of life. This extraordinary sensitivity ensures survival of species. Even in vast forests or fields, moths can find each other with astonishing precision. The perfume trail is both signal and pathway, cutting across chaos like a thread. For the moth there is no confusion, as the air itself becomes a guide. But it is not only about attraction. Some moths use these signals to avoid rivals or predators, detecting danger written in molecules carried on breezes. Others adapt their scents to deceive, imitating the signals of mates to mislead competitors. The invisible perfumes become not just guides but weapons in a chemical battle for survival. In their silent flights, moths remind us that air is never empty. It is full of perfumes and signals, hidden highways of scent, that direct journeys, encounters, and destinies we never see. Fish recognizing family through chemical signatures. Beneath the surface of rivers and seas, fish live in crowded schools, sometimes numbering in the thousands. How do they know which group to follow or which individuals are kin? The answer lies in chemical signatures. Each fish releases unique blends of molecules into the water, like invisible fingerprints. Other fish read these signals instantly, recognizing family, rivals, or strangers with ease. Salmon, for example, imprint on the smell of their home stream as juveniles. Years later, they return to that same stream to spawn, guided not only by magnetism but by chemical memory. To them, water carries identity, carrying the scent of birthplace like a permanent marker. It's a memory carved not in mind but in molecules. In schools, this ability keeps groups cohesive. Fish match the chemical cues of neighbors, ensuring they swim with kin and avoid outsiders. It also helps them avoid inbreeding, as they recognize relatives through scent and seek partners elsewhere. What seems like random swimming is actually guided by invisible lines of recognition flowing constantly in the water. Predators and prey interact in the same way. Some fish release alarm chemicals when attacked, warning others nearby. Within seconds, the group changes course, scattering or tightening for protection. The water becomes a messenger, carrying warnings faster than sound or sight ever could. This chemical language is silent, but it holds entire societies together. For fish, water is not neutral. It is alive, saturated with identity, warning, and memory. And once again, we realize what feels to us like emptiness is, for them, overflowing with meaning. The strange ability to sense heat like vision. Heat is something we feel with our skin, but for many animals it is something they see. Imagine walking into a room and not just feeling warmth on your face, but watching it glow in patterns around you. To some creatures, heat radiates like light, painting invisible outlines in the air. It is another sense layered onto reality, one that changes the rules of survival. This sense, called infrared detection, allows animals to find prey even in perfect darkness. Where eyes fail and ears fall silent, heat remains constant. Every living body gives it away. Some snakes, bats, and even beetles rely on this invisible glow, turning the world into a map of warmth. To them, the night is never fully dark. It is a canvas painted in gradients of heat. Think about what this means in practice. A mouse under leaves, invisible to sight, becomes a bright beacon in the thermal world. A bird, hidden in branches, reveals itself in warmth patterns against the cold sky. These signals do not lie. They cannot be covered up, because every heartbeat radiates energy. For animals with this gift, camouflage fails where heat endures. This power reshapes how they live. Predators track prey by its inner fire. Insects avoid flames by detecting distant heat. The invisible warmth around us, something we ignore, becomes a guiding system in the lives of others. It is not magic. It is physics sharpened into survival. And perhaps the most humbling thought, as humans we built technology, night vision cameras, thermal scanners, to see heat. Yet nature built the same ability into animals millions of years ago. They carry what we needed machines to create, showing once again that our inventions often echo powers already present in the wild. Pit vipers striking prey with thermal eyes. Among the most famous heat-sensing creatures are pit vipers. These snakes carry small pits between their eyes and nostrils, organs so sensitive they can detect temperature differences as tiny as a fraction of a degree. For them, the world is painted in two layers, one of ordinary sight and one of thermal vision. Together they create a superpower, the ability to strike prey with perfect accuracy, even in darkness. Imagine a viper lying in wait at night. The forest is still, shadows deep. A small rodent moves nearby, hidden by leaves. The snake does not need light. Its pits glow with the warmth of the rodent's body, forming a thermal image so precise it could be mistaken for vision. The viper strikes without hesitation, guided not by sound or smell, but by the invisible glow of heat. This adaptation makes vipers extraordinary predators. Even if their eyes are covered, they can still aim at moving warmth. Scientists have tested this, placing prey in complete darkness. The snakes still found them unerringly, as if light itself had returned. It is vision without eyes, awareness beyond ordinary senses. For prey, this ability seems unfair. Hiding is useless. Silence does not help. Yet it reminds us that survival is never about fairness. Nature equips each creature with tools that balance across the ecosystem. For vipers, heat vision is their edge, a refinement shaped by countless generations of patient hunters. When we think of snakes, we often focus on fangs and venom, but their real gift is perception. They remind us that seeing is not always about eyes, and that true awareness may come from senses hidden in plain sight. Vampire bats finding warm blood in total darkness. In caves and forests of the night, vampire bats reveal another side of heat sensing. These tiny mammals feed not by sight but by detecting warmth. Their faces hold specialized sensors that allow them to find areas of blood flow beneath an animal's skin. Even in total darkness, they know where the pulse runs strongest. To them, warmth is a map to survival. Picture a bat landing on a sleeping animal. It doesn't blunder randomly, it lowers its face, sweeping side to side, until the warmest spot appears, a place where blood flows closest to the surface. With surgical precision, it makes a tiny incision, drinking in a way that often goes unnoticed. This ability depends entirely on detecting differences of temperature as subtle as a candle flicker in the wind. Their sensitivity is so fine that they can distinguish between veins and surrounding tissue. It is not vision as we know it, but it is accuracy beyond belief. To a vampire bat, warmth glows like lanterns across a dark landscape, each pulse a signal of life waiting to be tapped. Though their lifestyle seems strange to us, their sense of heat shows how adaptable mammals can be. Instead of sight or smell, evolution tuned them to warmth, giving them a tool perfectly fitted to their needs. They thrive not through brute force, but through awareness hidden from ordinary perception. And in a way, they mirror our own tools. Just as doctors use thermal cameras to find veins, bats use their natural sensors. Once again, nature demonstrates that what we think of as technology is often just a copy of abilities animals have carried for ages. Beetles navigating wildfires by following heat alone. Not all heat sensing is about hunting. For certain beetles, it is about survival and opportunity. Known as fire beetles, some species can detect wildfires from kilometers away. They are drawn not by light or smoke, but by the heat itself, felt through special organs on their bodies. For them, fire is not danger, it is invitation. Why? Because wildfires create the perfect conditions for their larvae. When trees burn, fresh wood becomes available, cleared of competitors. Beetles arrive quickly, laying eggs in smouldering trunks before other creatures dare approach. Their young then feed on the wood, thriving in an environment born from destruction. Heat becomes both a beacon and a promise of life. These beetles carry sensors so delicate that they detect even small differences in infrared radiation. While other animals flee, they fly toward fire with precision, guided by signals invisible to most living things. To them, flames glow like road signs, directing them to new beginnings. It may seem strange to us to seek fire instead of fear it. But in nature, every force has two sides. What destroys for one can nourish another. For beetles, Fire is not the end of forests, but the start of renewal, a chance to carve out space in a crowded ecosystem. This sense reminds us that the invisible world is not only about survival, but about opportunity. By feeling what others avoid, beetles turn heat into hope, reshaping destruction into growth for the next generation. The hidden use of polarized light in navigation. When sunlight scatters in the sky, it becomes polarized. Its waves aligned in patterns invisible to the human eye. But to many animals, these patterns are clear and constant. Bees, ants, crickets, even birds use polarized light to navigate, reading the sky like a giant compass. What we see as blank blue or gray, they see as grids of orientation stretching across the heavens. Imagine standing in a desert where landmarks vanish and the sun hides behind clouds. For us, direction becomes guesswork. But for an ant, the sky is still a map. Its eyes detect the polarization of light, telling it exactly where the sun lies, even when hidden. With this, ants march straight back to their nests after long foraging trips, never wandering lost. Bees use the same trick. Their famous dances inside hives often point directions based on polarized light outside. Even when the sun is invisible, they can calculate angles of travel with astonishing accuracy. What feels like instinct is really a sophisticated use of invisible geometry painted in the air. For birds, polarized light may help during migration, offering backup cues when stars or magnetic fields are obscured. It is one of several invisible maps they carry, woven together into a system of flawless navigation. To them, the sky is not empty but layered with direction. And here is the marvel. This hidden compass is available every day above us, yet we never see it. The sky looks simple because our eyes are limited. But for animals tuned to polarization, the heavens are a living chart, pointing home with quiet certainty.